Sure, it's 12:10. All right, let's get started. Why is okay, cool. So as you may have all noticed, there is a QR code that you can follow to the class attendance form. I will ask that you fill it out every time you come to class, or come to class via Zoom, or watch a recording later. We'll talk about that a little bit more later. What I will say is I just recommend bookmarking the link because you're going to go to it every time. So instead of having to use the QR code every time, certainly welcome to, but it's easier just to bookmark it. So let's go ahead and go over the Canvas stuff. It's pretty straightforward, but I feel like we should talk about it just to make sure we've all got that under control. And then we will talk about math. So the nice thing about this class is that all of the Co-17C are taking it from the same instructor because there's only one. Tember Galiava, I believe is how to say her last name. Zanerki, I think is her first name, right? That's who you'll have, right? Okay, cool. So let's go ahead and look at the Canvas for Co-17C. Actually, before we look at this, let's just go to the dashboard real quick. I want to show you one or two things, really just one thing. So in case you're not aware, you can modify how your course looks just a little bit if you care to. I always like to go and change the nickname. So I like to write in Co-17C and then the days and times the class meets just so I know when it's going on. Sometimes also, like I also might write in the place it's meeting just so I can see that when I look at it. It's kind of nice. So that's something, and you can also change the color if you don't particularly like the color that I like. You can change it to, I don't know, to this nice teal color. Anyway, in case you didn't know, now you know you can change things on the dashboard like that. I think it's somewhat useful. But let's go ahead and check out our Co-17C class. So we'll read through most of this. If you have any questions, be sure to ask them. This is the homepage, it's the syllabus. I'll probably change the homepage to the modules because that's actually where you'll probably want to go to find anything useful in this class. But for now, we'll leave it here for maybe until Monday or something. Let's see, what have we got here? So the class meets Tuesday. Oh, I was going to change it to the student view so you can only see the things that you can actually see. It's not that big a deal, but there's a few things I've posted that haven't like been made published yet, so it's whatever. Let's see. So you're encouraged to come to class in person. That said, if you want to come via Zoom, that is totally fine. You're welcome to do so. You're also welcome to watch the recordings later if this time doesn't work for you. I'm James. And please call me James if you, I understand if you want to call me something else like Mr. Parmenter, that is also fine, or professor, even though I'm not a professor, or teacher, or something else. Mr. P is also okay, I guess, but I don't love it, honestly. But that's fine. Parmenter can be a mouthful. Anyway, the best way to reach me is to send me an email, preferably straight to me. You can use the Canvas email thing, but I'm less likely to see those right away because they go to like a different inbox. So it's easiest just to email me at my email address, jjparmenter@ucdavis.edu. You could also try calling my phone or coming by my office, but honestly, if you actually want to get a hold of me, email is the best way. You can find me in office hours. They are many and dispersed across campus. Starting, what is it, October 8th, Sunday, October 8th. So really starting Monday, October 9th. You can find me in math drop-in on Mondays and Wednesdays from 1 to 2, and Tuesdays and Thursdays from 3:40 to 4:30. And that's in the lower level of Shields Library where all the math drop-in is, along with the chemistry, stats, econ, physics. I'm sure I'm missing biology drop-in. It's all down there. So you can get help for lots of classes down there. Additionally, starting next Monday on the 3rd, that doesn't sound right. 2nd, 3rd, whichever day, I don't know. Whatever day next Monday is, I think it's the 2nd. You can find me on Mondays and Wednesdays from 10 to noon and Fridays from 10 to 11 in C class, which is the Center for Chicano Latino Academic Student Success. Anyone is welcome to come find me there. It's actually a great place if you actually want to get help because usually less students are looking for me there. So you get more individualized attention. And then on Tuesdays and Thursdays, right after this class, you can find me in CADS, which is the Center for African Diaspora Student Success. And that's right nearby. It's in the south silo on the 2nd floor. You can either take a little elevator up there or take the stairs that are by the market that's over there. I forget exactly what it's called, but you can find me there on Tuesdays and Thursdays. Again, a good place to find me because I'm relatively unoccupied compared to being in drop-in.
So can I come to you and give those?
Yes, total. Anyone can come to me. Yes. Yeah. What else? Grading. So this class is a pass no pass class. The passing grade is 75%. There are two things you have to do to pass. Thing one, you have to come. And importantly, fill out the attendance form. Even if I see your face and know your name here, like if I see that, you know, Olivia's here and Liz is here and Saya is here. And what's your name, sir? Mahmood? Mahmood. Here for 17C?
Yes.
Welcome. Have a seat. And I forgot your name. Jaslyn. Even if I see her here, if you didn't mark the attendance form, I'm still going to mark you absent. So just be sure to fill out the attendance form every time you come to class. And if you missed it, you can certainly scan it. Right there.
Is there a way to get the Canvas even though we're not enrolled?
Yes, definitely. So if you want to gather the Canvas, but you don't want to enroll in the class, I still ask you to fill out the attendance form, even if you're not enrolled, but just send me an email. In fact, let me write down my email because you might not be able to see it very well there. So my email is jjparmenter@theusual.ucdavis.edu. Yeah, just send me an email, ask me to add you to this class, Co-17C, and I will happily add you. And then you'll have access to all the Canvas stuff. Excuse me. The other thing I ask you to do is to fill out or do the weekly reflections, which are worth 30% of the grade. They're not hard. It's really just for me to kind of gauge what's going on in your class, see how you're feeling about it. They're weekly. It's really like, what's happening in class? How do you think you're doing in class? Maybe I ask you something like where you're from, or do you have any siblings? And maybe tell me a joke. It's optional, but I like jokes. So if you tell me a joke, I'll be happy. But really, like, there's no math. I'm just kind of gauging how things are going. So I do ask you to do that every week. It's pretty short and sweet. It's not hard at all. I think it's not too terrible. And then once again, here's the attendance form, just so everyone can see it. That's what it looks like. You'll put your email in there. You'll put your student ID number there. You'll write your name like you would usually write your name. I would write James Parmenter, not last name first, no commas, no other weird punctuation, just your first and last name. Preferably how it shows up in Canvas, just because that's the easiest way for me to see it. But if you call yourself something different, that's also totally fine, and I will figure it out. And then click on Co-17C, and then the way you attended, it would be live in person. And then lastly, if you are watching a recording for attendance as opposed to coming live, that's totally fine. So let's say you're watching this recording tomorrow on the 29th of September. You would still enter the date as 9/28/2023 because you're attending the class that occurred on September 28th, 2023. That's all I ask. And then submit. But I'm not going to submit because then it will give me too much data. I don't want the data. Questions about that? I think it's fairly straightforward. Try and make it fairly straightforward. Let's see. What else have we got here? So that's grading. Please fill out the attendance form as soon as you can, preferably the same day that you attended. I would prefer not to have like 20 attendance filling outs at the end of the quarter. I'm like, so fill it out as we go and make everyone's life easier, especially mine. If you're absent from class, you can always make up the class by watching the video and then filling out the attendance form. And you can either find the videos on Canvas or on the YouTube channel that is linked from Canvas, which is easy to find. And let's see, what else? Not passing the class is not the end of the world. It's a workload class. It doesn't really count for that much, but everyone can pass the class. It's not really that big a deal. So fill out the attendance form, do a few of the reflections, and we'll all be good to go. Questions about that? Cool. About this class. So let's see here. If something outside of this class is impacting your success, please don't hesitate to talk with me about it. I've definitely had students in the past come talking about like what is going on in their actual class, because there were sometimes some things that were challenging that we tried to help them deal with some grading issues. So if something's happening, you're welcome to come talk to me. I can try to help be a bridge to your professor sometimes. Sometimes I have better relationships with some professors than others, but happy to try to help if help is needed. If something is said in class by anyone, including myself, that makes you uncomfortable, either please talk with me about it, or if I'm the one making you uncomfortable, although I don't anticipate that because I'm a pretty easygoing guy. But if I say something that's terrible, definitely you can fill out the AATC feedback form. You can go to the Academic Retention Initiative Centers. So I don't think that's going to be an issue, but if for some reason I've said something that is terrible, let someone know, because I don't mean to, and I shouldn't be. But again, I don't think that's going to happen. So no worries. Let's see. Our class obviously is from 12 to 1:30 in this place. You're here. Good job. You found it. And yeah, as far as class goes, I'm going to be showing you examples. I might have you get up. So that's the hard part about Zoom. I would love to have you get up and use the boards and do problems, but since I'm also trying to cater to the people on Zoom and to the people watching the video later, probably less of that. I might have you work individually on stuff, like I might have us work for a couple minutes on a problem, and then I'll go back and kind of show stuff. But kind of unfortunately, over the last few years, it's evolved into me talking more than I really would like to be, but that's kind of the way it goes. Trying to also cater to the Zoom audience as well as the people in class. And this is what it is. It's nice for students to be able to watch the video later. So I think it's worth making that kind of change. Please come to class prepared to work on math problems. That usually means bringing a writing utensil and something to write with. I said the same thing twice, and something to write on. Whatever you like is totally fine with me. As far as accommodations, if there's something I can do to improve your ability to succeed in this class, or the class it's a co-class for, please let me know. Welcome, Co-17C. You here for Co-17C?
Yeah, of course.
Come on in, have a seat. In fact, a student in the last class just asked me if I could use a darker / thicker pen because she was having trouble seeing what's right. Also, the AV equipment in that room was less excellent than the AV equipment in this room. So hopefully that won't be an issue here. But again, if there's something I can do to make it easier for you to see what I'm doing or understand what I'm saying, like talking not as fast as I sometimes talk, let me know, and I will try to do my best to make things more accessible for everybody. And then if you have formal accommodations to the Student Disability Center, please do let me know. They usually, as far as the co-classes go, they usually don't amount to much, because often the accommodations are either extra time for testing or recording of the class lecture. Both, one, we don't have tests in this class, so you wouldn't need that. Two, I'm going to record the lectures anyway. Certainly you would be welcome to record this on your own as well. I don't have a problem with that at all. But both those things are totally fine. If there's something else though, please let me know. Or if there's just an accommodation you want me to be aware of, let me know. Yeah. Zoom instructions. I think everyone's probably pretty well versed in how to use Zoom these days. But if you aren't, please let me know, and I'm happy to show you how it works. You all, again, are welcome to attend via Zoom if you would like to. I would prefer / love to have you all in person, because it makes it easier for me to teach the live people. But if you want to come via Zoom, that is also totally fine. Excuse me. And then if you are on Zoom, you're welcome to use the chat to say things to me via chat. You're also welcome to unmute yourself and say words. You might make me jump because I'm often not prepared for that, but it's totally fine. What else here? As far as the co-class goes, the class is worth 1 workload unit, which means it counts towards being a full-time student for financial aid purposes and making minimum progress, but it doesn't count towards graduation or the 225 unit cap. It's typical. What else? I've never gotten students to do it, but I encourage you to use the discussion tab in Canvas to converse with me and with other students. You can ask me questions there and I can answer them, or other students can answer them. It's kind of like Canvas's version of, I don't know, maybe like a Discord server, but less interactive, I feel like. But the nice thing about it, the one reason I do try to promote it, is because there is a way that anyone is able to type in a nice mathematical typesetting way. So I can write math that looks nice and is easy to read. So if you ask me a math question there, I can answer it and make it look kind of pretty. Whereas other places, it might not look quite as nice. So that is one reason why if you have a question that you want help with, you might try asking it there. I might not answer it directly. I might be like, have you thought about this, or try this? But I will certainly try to be helpful. And the other students can also chime in as well. It is public. Other people will see it, but that's okay. We all have math questions. That's what we're here for. What else? Where can we get, oh, successful students usually spend what, 10 to 20 hours per week during homework? Yeah, that's fairly reasonable. You can count these 3 hours as 3 of those 10 to 20 hours, but really like that is a not unreasonable amount of time to be spending doing math homework, studying for math, writing things down, just kind of thinking about math. I would encourage you to think about math every day because math is great, but not everybody feels the same way. Still, I imagine for most of you, this is your last quarter of math. I mean, I think there's some like math 27A that's like linear algebra or something. It's a weird linear algebra class, but no, most of you, this is like the end of the road for math. So we're going to get through this class and be great, and then you can be done with math. Unless you choose to do more math later, which you can always choose. Where can you get more help? There's a few places, my office hours, see above. Grant's website is always a useful place to go look for resources, handouts, extra problems. Pardon? Yes, so Grant's website does have 16C stuff as well. I would encourage you to look at that for sure. And then there's our AATC tutoring website, which you can make appointments with student tutors. You can also see when the drop-in. So I'm in drop-in tutoring, the hours I mentioned, whatever they were. I forget, Monday, Wednesday, afternoon hour, Tuesday, Thursday, other afternoon hour. But math drop-in is open. And I imagine many of you know this already because you have taken classes here before, but it's open Monday through Thursday, 10 to 5, Friday, 10 to 1, and Sunday, 3 to 7. So you can go there and get help from mostly student tutors, occasionally myself or Grant or Sarah or Jen will be there, who are the math specialists, but mostly student tutors who are also very helpful. All right. And then of course, each other. You are all a great resource to each other. I really, really, really encourage you to get to know the people sitting next to you, because I think you can make great study partners and kind of help each other do better in this class. So I would definitely recommend that. Maybe on Tuesday, if you get to class before I do, or even before class starts, just talk to each other, try to get to know each other, maybe study together. That's definitely what I think is a great way to learn math. I certainly utilized that when I was a student here and studied with some other fellow math 21A students, which is what I was taking at the time and many years ago. And it was very helpful to have other people to study with and to ask questions too, and to think of new questions, like what kind of question do you think is going to be on the test, and coming up with new stuff. It's really a good way to help each other out. So there's all the nuts and bolts. Let's go ahead and look at actually the more kind of important part of Canvas, which is the modules, because that's where you'll actually find stuff that is useful, I think. So here's all the same kind of links again in a more condensed area. There's a link to the attendance form, a link to the Zoom if you need to attend via Zoom. Here's a link to my 17C playlist on YouTube. It has all the videos from the last, I think, couple times I've taught this class, and it will have all the videos from class currently. So after class today, I will upload the video to YouTube, and then I'll, also post it to Canvas. Likewise, the class notes that I'll write during class, I'll post in a Google Drive, and you can find them there or on Canvas. Here's where my office hours are again. If you don't remember what they are, you can look there. Grant's website again. And then actually, we should look at this for just 1 second here. So these video lessons are not on YouTube, but there's some 17C videos created by math AATC specialists, AATC math specialists. And if you scroll down, you can just see eventually that there are videos by chapter and section. So if you're looking for some videos in section 9.1, lots and lots of different ones here you can check out. And they are usually pretty well labeled. So if you're looking for something specific, I think you can find it. And yeah, we could look further, but you get the idea, I think. And they're not long. I think some of them are maybe a little bit long, but I think most of them are relatively on the shorter side. So unlike these class videos, which will be like an hour plus. So yeah. And then, oh yeah, some links. I do think these links are worth checking out, especially for this first chapter, chapter 9, 3D graphing. It's nice to actually kind of be able to see what something looks like, even though you're not really typically going to be asked to graph something three-dimensionally usually. It's still nice to kind of have an idea of how things look. So you have 3D graphing in Desmos, which is not the best because it's just kind of a thing someone made up on their own. It's fine. But I would say the 3D graphing in, whoops, that's not what I meant to do. The 3D graphing in GeoGebra is much nicer. And we might even use it today. So you can, this thing is always in the way. There we go. So you can graph all kinds of fun stuff over here, which we won't do just yet, but we'll probably come back to that. Excuse me. And then finally, later on, when we start talking about finding equilibria and solutions to a linear system of differential equations and using eigenvalues and eigenvectors like you did at the very end of 17b, that's when you're going to want to maybe look at the graph of a phase plane. So there's a link to that as well. Again, you're typically not going to be asked to graph them because they're tedious to graph, but it is nice to be able to see what's happening. So definitely don't forget about this. And I'll remind you of it when we get there. I think that's chapter, I want to say chapter 10, but I don't remember for sure. And then finally, at the very end of the quarter, like the last week and a half, 2 weeks, we start talking about probability for whatever reason someone decided that's what we should end with. There is a nice handout here with some terminology, and it's got like how, if you've never played with a deck of cards, it's got a deck of cards there and kind of how the names and stuff work for that as well. So it's a good handout to look out for the probability stuff. And I think that's all I have to say as far as our class canvas goes. Questions? Yeah.
So you said that we don't necessarily have everyone in class to ask us.
Correct. Yes. And you can do that by emailing me there and then asking me to add you, and I will add you, no problem. The only thing I ask is whether you're actually enrolled in the class or just added to Canvas to please fill out the attendance form every time you attend, because even if you're not enrolled, we still try to collect the data on how many students we serve, because that is part of how our department is. It's not like the main way we're funded, but we certainly do get some funding based on how many students we serve. So it's important that I keep track of that data. So please do fill it out whenever you can. Other questions? Hey, Jaslyn,
Yes.
Olivia, Mahmood. I've got, it's in my head now. Saya. That's okay. I think I got it. I don't know your name.
Is it?
Is it?
Is it?
Sorry, is that one time?
EASO.
EAS. Easton?
Yes. That's it.
Kind of, a little, like, you look very familiar. I was like, I'm not sure. Yeah. Yes.
I mean, 17.
Yes.
Yeah, I mean, there are the profiles.
Right.
Yeah.
Liz. Oh, I forgot. Leo. I should know. I am a Leo. Leo.
I'm actually not.
How unlucky you are. No, I'm just kidding. Okay. Any other questions about the nuts and bolts before we start talking about the math? See if I can get organized here. Okay, let's see. Let's see paper. I should say also, if you find my writing too small, which it sometimes is, please let me know. I can try to write bigger. There was something else as well. No, I guess that's it. Yeah, I will try not to write too small. It's sometimes a challenge for me. Honestly, the challenge is sometimes I'm trying to like squeeze something into the end of the page. I should just use a new piece of paper. So I will try my best not to do that, but it's hard not to sometimes. Let's see if we can get this looking good. Okay. Should be smart about this. All right, we're sending it up. And again, for those of you on Zoom, please, if you have questions, feel free to ask them. You can throw them in the chat. If I don't see it for some reason, you're always welcome to unmute yourself and say, hey, James, I have a question, and you're not addressing it. That's really fine. All right, so you had class yesterday. Did you talk about any math? A little bit. I'm imagining you might have talked about 3D graphing or level curves, or, well, let me ask, what did you talk about?
Define function.
Okay. Okay. And imagine a function of two variables?
Yeah.
Okay. Cool. Let's, yeah, right on. Okay, yeah. Because circles kind of come up a lot in these functions of two variables because mostly because they're easy, kind of. So let's look at an example. Let's see. Today is the 28th. So yeah, sure. Functions of two variables. And here is a pretty typical example. Let's say f of x comma y is equal to the square root of 9 minus x squared minus y squared. And we're going to do a lot with this example. We're going to find the domain, we're going to find the range, we're going to graph some level curves. By the way, when someone says level curve, what you should think of is like topographical map. A level curve is just a curve on the map where the whole kind of curve happens to be at the same elevation. That's what a level curve is. All of that line or curve or whatever kind of wiggly thing you've got is all at the same height above ground, with the same height above the XY plane. And actually, just for, this is not great for the people at home, but for the people in the room, I will often kind of refer to the corner of the room, that corner over there specifically, as the origin. So I like to think of, sorry, I know everyone's think this is not great, but I like to think of this is the origin. There's your x-axis pointing out towards you. There's your y-axis moving horizontally, and there's your z-axis going towards you. And often a point of reference I will use. Okay. So let's talk about this. So let's talk about the domain first. So just like in 17a, when we talked about domain, in 17a, in fact, let's kind of do an analogy here. Here's our 17a analogy. If your function was, say, like the square root of 7 minus x, then your domain would be all the things x was allowed to be. So here our domain would consist of, well, we need everything inside the root to be greater than or equal to 0. Here, that's easy to solve for. We can add x to both sides and say 7 is greater than or equal to x. Or if you prefer, if some people don't like moving x to the right-hand side for some reason, you could also subtract 7 from both sides and say negative x is bigger than or equal to negative 7, and then multiply both sides by negative 1 to get x less than or equal to positive 7. Because then you multiply both sides by a negative, you have to change the order of the inequality. Either way, you're getting the same thing. X less than or equal to 7 or 7 bigger than or equal to x. Those mean the same thing. So here, if I was writing the domain as an interval, I'd write it as the set from negative infinity up to 7. Because at least for functions of one variable, the domain is just an interval on the x-axis or on the number line. It's not going to be exactly the same for functions of two variables. But the process is still the same. The idea in that we're just looking for the things that x and y are allowed to be. Just like here, x had to be less than or equal to 7, right? It couldn't be 8 or 9 or 10 because you can't take the square root of a negative number and get a real result. Same idea is going to be true here. For our domain here, we need everything inside the radical to be greater than or equal to 0. This is where things get a little bit different, because we can't just solve for x or solve for y here. Typically, when you have what I think of as an x squared plus y squared, or really I should say where x squared and y squared have the same sign, we usually kind of think of them as a grouping. I might think of rewriting this as 9 minus parentheses x squared plus y squared greater than or equal to 0. And then kind of treating that as its own unit and adding that to both sides. So I'm going to get 9 is greater than or equal to x squared plus y squared. Or because, I don't know, because I've learned math in this system, I like to write my variables on the left-hand side. I might write that as x squared plus y squared less than or equal to 9. And there's not much more you can do with that as far as how you're going to write the domain. So here's our very, I would say, unsatisfying way of writing the domain. So watch this for a second. It's the set containing all points x comma y such that, and then you literally just write down the condition that we just found. X squared plus y squared is less than or equal to 9. That is honestly probably the most efficient way of writing what the domain actually is. But it doesn't tell us a whole lot. Really, what we'd like to do is actually graph the domain. And that's definitely what I know, like in some of these homework problems, that's definitely what your teacher wants you to do, is graph what the domain looks like. So when graphing a domain like this, what we usually do first is, instead of trying to graph this inequality, x squared plus y squared less than or equal to 9, we're going to graph the equality first. So we're going to graph, see if I can keep things on the page here. So we're going to graph x squared plus y squared equal to 9. Which is why we have been talking, or you might have been talking about circles in class, because x squared plus y squared equal to some number is the graph of a circle. Specifically, this is a circle centered at the origin. And what's the radius? Square root of 9, which is 3. Just as a quick aside here, the general equation, or the standard equation of a circle with center h comma k and radius r is given by x minus h squared plus y minus k squared equal to r squared. Most circles you see in this class, at least when you're talking about domain stuff, will probably be centered at the origin. They'll probably just look like x squared plus y squared equal to some number, some radius squared. I will point out you could write this as, although we wouldn't, x minus 0 squared plus y minus 0 squared equal to 3 squared. No one would ever actually write this circle that way. They would always just write it as x squared plus y squared equals 9. But this kind of more emphasizes, oh yeah, the center is 0, 0. The radius is 3. Okay, so we're going to graph it. Now, as far as how I'm approaching graphing this, I know that the actual domain is x squared plus y squared less than or equal to 9. Since it's a less than or equal to, specifically the equal to part, I know I want to include the boundary, because any point on the boundary is satisfying the inequality, which means I'm going to draw it as solid. Whereas if I was trying to exclude it, I would draw it as dashed, which we'll do for the next example. So 1, 2, 3, 1, 2, 3. Draw your best circle you can. Pretty good, not too shabby. And now here's what you do after this. Whenever you're finding a domain and you have some sort of boundary, your domain is always going to be entirely on one side of that boundary. So it's either going to be, in this example, everything inside the circle, including the boundary, or everything outside the circle, including the boundary. And all we have to do is test one point to see if it's everything inside, everything outside. So let's say we're going to test the point 1, 1. So if I do that, looking back at the inequality, x squared plus y squared less than or equal to 9, is 1 squared plus 1 squared less than or equal to 9? I think it is, right? 1 plus 1 is 2, 2 is less than 9. Yes. That means that that point is in the domain, and so is every point that is on this side of the boundary. So our domain looks like everything inside the circle and including the boundary of the circle. So if I was trying to describe this using words, the domain is all points inside and on the circle of radius 3 centered at the origin. Those are the words we would use to describe the domain. Question so far? Just to reemphasize one more time, I just want to make sure everyone is clear. The domain is not going to be an interval, right? It's not like everything from -3 to 3 or something like that. It's every point inside this circle. So 1, 1 and 2, 1 and probably not, no, 2, 2 is also in there, but also all sorts of irrational things like -√3, 0 and an infinite number of points inside this circle. Cool. Also, yes, if you need to leave early, totally fine. Don't feel like you need to check with me. I understand some people might have conflicts. Really come and go as you need. That also is true for the restroom. If you need to use the restroom, don't check with me. Just go use the restroom. Totally fine. All right, that's the domain. Let's talk about the range. Range can be terrible or not, depending. So again, we're looking at this function, the square root of 9 minus x squared minus y squared. And honestly, the range is kind of a hodgepodge of methods. It's usually thinking about how big and how small can this be. And I find it really, really helpful to rewrite this as square root of 9 minus x squared plus y squared. And it's a really important observation to make that we know for sure that x squared plus y squared has to be non-negative. It's always greater than or equal to 0. X squared is always bigger than or equal to 0. Y squared is always bigger than or equal to 0. And if you add them together, the result is always bigger than or equal to 0. And in fact, the only way it's ever equal to 0 is if they're both 0 themselves. 0 squared plus 0 squared equals 0. And if you plug in anything else for x or y, you're going to get something that is larger than 0. So that helps because then we know that the smallest this can ever be is 0. So if we're trying to, and again, if I'm trying to make my function big, so if I'm trying to make f of xy big, I want to make the thing I'm subtracting off as small as possible, right? If you're trying to make something large and you're subtracting something from it, you make it large by subtracting as little as you can. And the smallest thing that can be is going to be 0. So the biggest this can be is when you plug in 0 for x and 0 for y. And you get the square root of 9 minus 0 squared plus 0 squared, which is just the square root of 9, which is 3. How can I make f of xy small? Well, maybe here's a more important question. What's the smallest value a square root can ever kind of return to you? Or as I usually say, spit out. Could I get the square root of something being -3? No, I couldn't. Right? When you take a square root of a number, you only ever get positive, actually technically non-negative results. You can get positive numbers or 0. So 0 is the smallest thing you can ever get out when we take a square root of a number. Can we get 0 here? Is 0 even an option? I think we can. I think we can, if we pick smartly, we can pick an x and a y value that will give us a 0 function value. Anyone want to venture a guess? There's multiple right answers. So let's see, I could pick maybe, I don't know, -3 for x and 0 for y. If I do that, and that's in my domain, right? That's actually at the very end of my domain right there, or I should say on the border. It's not really the end. If I plug in those points, I get the square root of 9 minus -3 squared plus 0 squared. But that's the square root of 9 minus 9, which is the square root of 0, which is 0. So I definitely can get a 0 result. That's the smallest the function can be. That's the biggest the function can be. And I definitely can get any value in between. right? If you wanted me to find, make it equal to the square root of 5, we can make that happen. So it looks like here our range is everything from 0 inclusive to 3 inclusive. And the range will look like your typical kind of range, where it's just an interval from somewhere to somewhere, or maybe a union of intervals, but like it's your usual kind of way we think of range, whereas domain's a little bit different. Let's see, there was something else I want to talk about. Oh yeah, we should talk about the level curves. So we want to kind of have an idea of what this shape might look like. And so what we're going to do is we're going to look at what are typically called level curves. So level curves, or really just what 2D shape does the three-dimensional surface have at varying elevations or heights. The elevation's a funny word to say. That's the whole idea here. If you go, right, if you start like on the ground floor and you go higher and higher and higher, and you like essentially slice the surface, what kind of shape are you getting? Yeah, I don't want to say it. No, I don't want to say that. So I will point out, we can only go to heights that are in the range, right? The range is essentially the z values. And for lack of a better term, we think of z as the height of the function. Just like in 2 dimensions, if you have y as a function of x, we typically think of y as the height and x is how much over. Now we're in 3 dimensions, we're thinking of x, y as like where we are in the plane, is the floor, and then wherever we are on the floor determines how high the function is. So if I went over to the point, -3, 0, I get a height of 0. Because if I go to the point 0, 0 at the origin, well, I'd actually go up 3. I'd go to 0, 0, 3 because my height would be 3. So what we're going to do is we're going to pick some different heights. And really, we only have a few choices here. So we're going to pick the heights of 0, 1, 2, and 3. Because those are really the only options we have. That's not entirely true. You could totally pick fractional values or irrational values in between those, but we often like to limit ourselves to integer values because it's easier to think about what's happening there. So c equals 0. For some reason, we've decided that we use c for our level curve value. Some people might use z as well because we're just talking about how high we're going. So we're just going to say, great, we're going to set the function, which is the square root of 9 minus x squared minus y squared equal to 0. Question?
Yeah, what are the C values?
So the c values are the, oops, sorry. Sorry, I meant to do that. The c values are just the heights that we're going to pick. So when I say c equals 0, I'm thinking, oh, we're asking what does the 2-dimensional curve of the surface look like if we go to a height of 0, or if we cut it with the plane that is at z equals 0. But we like to use c. I don't actually know why, to be really honest, why someone decided we should use c instead of z, but we do. So the idea now here is to try to solve for this in a way where it looks like a recognizable function. Often, if you have just y and x, it means solving for y as a function of x. It's not the case here. We already know what kind of things we're going to get here. We're going to get circles. So what I'm going to do is I'm going to square both sides. Make it 9 minus x squared minus y squared equal to 0. And I'm going to add x squared plus y squared to both sides. So I'm going to get 9 equal to x squared plus y squared. Or in other words, I would prefer to write x squared plus y squared equal to 9. Sorry. So at a height of 0, I know that I have a circle of radius 3 center of the origin. And yeah, I can probably fit this in down here. Sure. So at and if you have multicolored pens or pencils, this is a great time to use them because it's nice to kind of be able to distinguish between level curves that are next to each other. So here's my level curve. circle of radius 3. And that's when my height is 0. So now let's look at c equals 1. Now, this is where things get a little bit tedious, and I really should jump ahead, but I'll do it one more time and I'll talk about kind of an easier way to do it. So what we're going to do now is we're just going to set the square root of 9 minus x squared minus y squared equal to 1 instead of 0. We're going to square both sides, get 9 minus x squared minus y squared equal to 1. We're going to, I don't know, we're going to do the math. 9 minus 1 is 8, x squared plus y squared on the other side. We're going to end up with x squared plus y squared equal to 8. So here we have a circle with a radius of the square root of 8, centered at the origin, which is approximately 2.8. So kind of close to that circle there. So now my drawing skills come into question. And it doesn't have to be perfect. So we've gone up and our circle got a little smaller. Still with the same center though. Here, c equal to 1. Okay, so now instead of doing this every time where you just keep plugging in a new value for c and solving until you get x squared plus y squared equal to something, here's what people actually like to do. Like to say, okay, instead of doing this, let's just set square root of 9 minus x squared minus y squared equal to c, and then solve in the same sort of way. Square both sides equals c squared, sorry. And then I would subtract c squared and add x squared plus y squared to both sides. So we end up getting x squared plus y squared equals 9 minus c squared. That's a circle. What's the center? Well, not everybody at once. What's the center? Right. So 0, 0, the origin. And here when this was 9, the radius was the square root of 9, which is 3. Here when this was 8, the radius was the square root of 8, which was about 2.8. And here it's x squared plus y squared equals 9 minus c squared. So the radius is going to equal the square root of 9 minus c squared. So if c is 0, the radius is the square root of 9. If c is 1, the radius is the square root of 8. If c is 2, the radius is going to be the square root of 9 minus 4, which is 5. And if c is 3, it's not very exciting. The radius is going to be the square root of 9 minus 9, which is 0. Which means it's not really a circle, it's just like a tiny little point. Square root of 5 is a little bit bigger than 2. Like right there. Oh, wow. Sometimes your circles don't look great. It's okay. You don't have to be perfect. So those are the level curves. This is my topographical map saying, okay, great. As I move closer towards the origin, my circles get smaller, but also higher. What we really have here is a hemisphere, right? If you graph this 3D surface, which we'll graph in a second, it looks like a hemisphere. It's got a circle as the base, and then as you move inwards, the circles just get smaller and smaller and higher and higher. If you were describing this using words, like on the web work assignment, you would say that we have concentric circles unevenly spaced apart. And we know that they're unevenly spaced because we picked evenly spaced values of height. Right? We're going up 1 every time. But every time we go up 1, we're not going in the same amount. Right, from 3 to the square root of 8, and from the square root of 8 to the square root of 5, and from the square root of 5 to 0, that's not equal spacing. Those differences are not the same. Questions?
Basically like slicing orange.
Exactly like slicing an orange. So if you sliced an orange in half, and then a little bit higher, and a little bit higher, and a little bit higher, you would exactly get these circles that were smaller and smaller and smaller, but higher and higher up. Excellent. I know I should have brought, actually I haven't, that's not a great orange for slicing though. Sure, so what I was doing for this first one here, which you can't see very well because it's in the way there. My face always in the way, sorry. So for this first one, I set it equal to 0. And then, and this is really kind of the thing you have to kind of learn with practice. If you see x squared plus y squared or minus x squared minus y squared, you typically want to isolate those things on their own side where they're both positive. So I took this and like, oh, I've got x squared plus y squared or minus x squared. So I'm going to square both sides and then bring the x squared plus y squared to their own side. And I'm like, okay, x squared plus y squared equals 9. I know that's a circle centered at the origin with a radius of 3. And then after that happens once, I kind of know the same thing's going to happen every time. I'm just going to get different radii. So here, when I said I'm going to go up to now a height of 1, same process. Set my square root of 9 minus x squared minus y squared equal to 1. Square both sides. Solve for x squared plus y squared. So I didn't show my work here. I really should have been like 9 minus 1 on the left equals positive x squared plus y squared on the right. And then I rewrote it like that. So this is the same idea, circle, centered at the origin. But now, excuse me, here my radius was 3. Here my radius is the square root of 8, which is a little bit smaller. Not a lot smaller. And then after that, I decided I didn't want to keep doing the same work over and over again. So I said, let's just set my function equal to c, and then I can solve for x squared plus y squared in the same sort of way. So I squared both sides. I subtracted c squared. I added x squared plus y squared. And then I said, I've got x squared plus y squared equal to 9 minus c squared. I know that's the circle again, centered at the origin, and my radius is just the square root of this. So when c equals 0, my radius is 3. When c equals 1, my radius is the square root of 8. When c equals 2, my radius is the square root of 9 minus 4. And when c equals 3, my radius is the square root of 9 minus 9, which is 0. So as I go higher and higher and higher, my circles have smaller and smaller radii. And so here's how we would draw this if we had to in 3 dimensions. We'd say, okay, well, we're going to try our best here. So usually when I draw my XYZ coordinate system, I'm thinking of the YZ part essentially looking like it's flat on the paper. Right, the YZ plane is this plane right here. The XY plane is the floor, and the XZ plane is the sidewall over there, which is annoyingly kind of slicing out at you. The x-axis points towards you, the y-axis points to your, the positive y-axis points to your right, and the positive z-axis points upwards. So here's your x-axis shooting out at you, and then I know that I'm going to go 3, 3, 3. And what I'll say about this is, if you're trying to make things look accurate, your distances in your y and your z-axis should be look the same, meaning moving over is the same as moving up. Whereas your x-axis, you're taking the same distance and then you're tilting the perspective. So even though this pen is as long as it was when before I did this, it doesn't look as long anymore because I've tilted the perspective. So the values along the x direction should look smaller than they actually are. I usually don't draw them in. I just kind of think like, I'm going to draw a circle in the XY plane. So I'm going to do like that and like that. So there's my circle in the XY plane. And then I know it goes like that. I can do like this too. So there's my hemisphere. And if you really like, okay, I'm trying to get a little brave here. Let's see if I can use the same colors. I can be smart. Yeah. I already kind of didn't use the same colors a lot. So here's my level curve at a height of 1. There's my circle of radius square root of 8, elevation 1. And then going up to an elevation of 2. It's a little challenging. My drawing skills are they're not always excellent. I'm trying my best here. There's my circle at an elevation of 2 with a radius of the square root of 5. So that is totally right. Those, even though I didn't match the colors because I blew it, but right, those are corresponding to the right. My outermost circle corresponds to this outermost circle at height 0. And then the red circle is this red circle at a height of 1. And then this black circle here is the same as this blue circle here at a height of 2. And then this very top point here is my circle of radius 0 at a height of 3. Cool. So that's the idea of level curves, is that you can kind of look at this and visualize what the three-dimensional surface actually looks like. Much like you could use a topographical map to kind of have an idea of what the actual mountain range might look at. And where you have a bunch of like lines really close to each other, that means it's really super steep because you're increasing your elevation very quickly. Whereas if you have lines further apart from each other and the lines representing further higher and higher elevation, they're further apart, it's a much more gradual increase. So it's actually a really useful skill to have, is to be able to read the topographical map and be like, okay, I'm going to go that way because I don't want to go up the super steep cliffside. I want to go up the more meandering, taking some I forgot, switchbacks and stuff like that. So yeah. All right. What time is it? 1:06. We end at 1:30. 1:30. Okay, cool. Okay. Let's look at some more examples. Yeah, question.
I know. One thing,
Mhm.
this, but, is this part of 16C?
So I do believe you do some of the 3D graphing at some point in 16C, but it might not be the very first thing you're doing. I don't remember right off the top of my head where you start off in 16C. I think it's more with differential equations.
Yeah.
So again, you're certainly welcome to sit in, but things might not really match up very well.
If it's good.
Sure. All right, let's look at another example. Let me take a quick look here. Sure, that's fine. So let's say we have, let's look at something like this. Let's say we have f of xy is equal to the, sure, let's make it fun. Log base 2 of 16 minus x squared. Nope, I want to go the other way. Sorry, I want to go x squared minus y squared. Apologies. Excellent. Sorry. Try again. Example 2. F of xy is equal to log base 2 of x squared plus y squared minus 16, James? Sure, why not? Minus 16. And we're going to look at all the same sort of stuff: domain, range, level curves, etc. So again, for domain, I'm like, did I really want that? Yeah, I really did. Okay. So for domain, same idea. We're trying to think about what kind of things X and Y are like. So typically when you're thinking domain, there are 3 things you have to worry about. Can't divide by 0. Okay, there's no division here, so no worries. We can't take the square root of negative numbers like in the previous example. So we set the inside of the square root to be greater than or equal to 0. And for logarithms, we can't take the logarithm of 0 or a negative number. So for a logarithm, you have to set the argument to be strictly greater than 0. So we're going to set everything in the logarithm, x squared plus y squared minus 16, to be strictly greater than 0. And just like last time, we're going to isolate the x squared plus y squared. So that's equivalent to saying, my battery is running low. Oh no, I didn't bring my plug with me. All right, oh, that was, let's see, is there a plug here? Sorry, 1 second. I just want to make sure. I dumbly took my plug out of my bag because it was in the way. That was not smart. Well, Zoom people, if I go away, I apologize. I'll be sure. Oh wait, maybe I'm in luck here. Well, maybe not. Why would you make this so impossible? They're not like long enough, really. It's like almost long enough to plug in and still stay over here, but not quite. Let's see here. Let's see. Can I be smart? Nope, I'm not that smart. Well, we'll wish ourselves good luck, and if it goes away, I'm deeply sorry. And I will be sure to bring my battery and charger next time and every time after that, because obviously I should have. It was in my backpack. Yeah. Okay. Anyway, let's try and do as much as we can before the video dies. So x squared plus y squared greater than 16. which again is looking like a circle. So we're gonna say, well, we're gonna graph x squared plus y squared equal to 16. Now, here's what I'm gonna do this time. Since I know that my inequality is a strictly greater than, not greater than or equal to, I'm not gonna want to include the boundary when I graph it. So I'm gonna draw it dashed. So I know that this is a circle. Center is the origin. My radius is 4. 3, 4, 1, 2, 3, 4. And so I'm going to draw that dashed as best I can. And then just like last time, I'm going to test the point. So again, let's test the point 1, 2, which is right there. Which clearly, so you should test the point that is obvious to you whether it's inside or outside of the circle. Usually the origin is the best choice, but I'm trying to make different choices just because it's nice to see different values. So we test that point right there. Let's see. 1 squared plus 2 squared is equal to 5. And is that greater than 16? Obviously not. No. So this point is not in the domain, which means this side is not the side we want. We want everything outside of the circle and